Welcome. This is Professor Adams. Today in this video we will look at graphs, and in particular we're going to be looking at graphs of lines. By the end of this video you will have learned how to graph a line using the slope and the intercept. You will have put the equation of a line in slope-intercept form. You will have used a point-slope form to write the equation of a line. You will have learned how to write and graph horizontal and vertical lines. And you will have learned how to find the equations of parallel and perpendicular lines given by a particular line. Before we start, though, let's do some warm-ups. Let's talk about what I have for the first one, which is the absolute value of x minus 3 is equal to 5. And why is that is different than solving for x minus 3 is less than 5? Well, the first one is an equation. Because it's an equation, I would set it up with 2. I have to set it up with 2. Let me write this in black. X minus 3 is equal to 5, or x minus 3 is equal to negative 5. And I would solve those two equations. And I would expect two answers, two values for x that will make that a true statement. On the inequality, however, I can either write it as two separate inequalities, or I can write it as a compound inequality. If I write it as two separate inequalities, I would write this as x minus 3 is less than 5, and, not or, and negative 5 is less than x minus 3. And I would solve that. And I would expect to have an interval of numbers for which that is the solution set. Like I said, though, I could write this as a compound inequality. And if I write this as a compound inequality, I would write as negative 5 is less than x minus 3, which is less than 5. And then I can solve it simultaneously. Because it is a less than. I could do this with less than or equal to. If it was a greater than or equal to, I would have to break it apart into two separate inequalities. But the real difference between an inequality and an equation is that with an equation I'm expecting potentially a couple of answers, and with an inequality I'm expecting an interval of answers. If I look at number 2, these are going to be similar. Now I said the first one wasn't. On number 1 they weren't completely similar. On number 2 they're more similar, and that's because of the fact that the value, the absolute value, is either equal to 0 or less than or equal to 0. That's the important part, is the 0. Because I'm not going to be able to I could, but it makes no sense to, bust this apart into two equations where I have x plus 4 is equal to positive 0 and x plus 4 is equal to negative 0, because 0 doesn't have a negative or a positive on it. So on this one, I would write this as x plus 4 is 4. Let me erase that. Sketchy, you guys. Oop, wrong one. I need to erase this. It is 4, just like 5 today, I guess. 4 is equal to 0, and I would solve, and I have x plus 4 is less than or equal to 0. And I would solve. I wouldn't need to do two of them. Now, the last one is just making sure that you're comfortable and confident with solving linear equations in one variable. Remember, on the right side of the equal sign, I would have to distribute that 2 through. So, start you off, I have 3x plus 4 is equal to, and I distribute the 2 to x, I distribute the 2 on the 5, and I would combine up like terms on the right side of the equation. So 3x plus 4 is equal to 2x minus 3. Go left with the x's, right with the constants. Minus 2x, minus 2x, minus 4, minus 4. And I'd end up with x is equal to negative 7. And my curly brackets, again, bear with me, need some work. There they go. So that's how you do those. Let's get to the meat of why we're here, though. We're here to talk about graphing, and in particular, we're going to be looking at the rectangular or Cartesian coordinate system. The left-hand graph, right here, is just showing you what the layout is for a Cartesian or rectangular coordinate system. The origin is where the x and y axes cross. Here is your x. Here is your y. The origin is right there where they cross. And these are done in quadrants. So in the first quadrant here, my x is positive, my y is positive, and My points would be ordered pairs. My ordered pairs would be the first part of the ordered pair would be the x part. The second would be the y part, but they're both positive in that quadrant. In the second quadrant, my x's are negative, but my y's are positive, so my ordered pairs with a negative x and a positive y would be in that quadrant. Quadrant number 3, I have a negative x and a negative y, so if I have an ordered pair that both the x and y are negative points, it will be down in quadrant 3. Quadrant 4, I have a positive x and a negative y, so I have ordered pairs in which the x is positive and the y is negative. It'd be down on quadrant 4. And then, of course, if I am actually on the axes, if I was right here on this point, my ordered pair would be 5, and I am right on the x-axis, so y is 0. If I say was right here on this point, then my x is 0 because I'm on the y-axis, and my y would be negative 2. All right. So when we look at graphing lines, we talk about the slope. And what the slope is the change in y to the change in x from one point to another. So as we take a look at the example here, here's my first point. My first point right here is 2, 1. I'm over 2 units on the x and up 1 unit on the y. My second point is 4, 5. 4 units on the x, 5 units on the y. Now the slope is the change in the y. I'm going to use delta y, that means change, over the change in x, delta x. I'm going to use delta for change. That triangle means delta, that's for change. So if I take a look at this, I'm going to count. I'm going to count my change in x. So from this point right here, and I'm going over here, I have moved 2 units. So that's my x. And it's positive. I've gone to the right, so it's a positive movement. If I look at my point where I end, so I'm going to go up to where I end, right there, I have gone up 4 units in the y direction. So it is 4 over 2, and up is positive. So up is positive, right is positive. Let's talk about if we would have gone the other way. So my slope, when I get done, I need to reduce these fractions if I can, and my slope is a positive 2 over 1, or just simply 2. If I decide to go from 2, I'm going to do it the other way. If I decide to go from 2, 1 to 0, negative 3, I'm going to do the same thing. So I'm going to count to the left 2. So in this case, I go left, so I go negative 2. And then I go down 4. And down is negative, so I go down 4. So again, the slope, whether I go right and up or left and down, because these are both positive, it's still going to end up with 2 over 1 or just 2. So it doesn't matter which way you go from a starting point to your next point, just as long as you think of right as positive, up as positive, left as negative, and down as negative. All right, so we are working on equations of lines that will be graphed in the Cartesian or XY plane. Our first definition, a linear equation in 2 variables, is ax plus by equals c. A, b, and c are constants. They're real numbers for us right now. And the variables are x and y. B can be 0, a can be 0, but they both can't be 0. We can end up with 0 is equal to some number, or 0 is equal to 0, and that's not interesting. And it's not an equation of a line. Our theorem, then, from our definition, is ax plus by equals c. Again, a and b both can't be 0, is a line in the Cartesian coordinate system. We talked about slope on the previous slide, and I used delta. The slope, m, of a line is the change in y over the change in x. I use delta y over delta x. But delta just means change. It just means change. When it's in ax plus by equals c, this is called standard form. It is not the easiest way to quickly graph a line, but it is in standard form. What we'll want to do is put it in y-intercept, slope-intercept form is what we want to put it in. If we are given 2 points and we're asked to find the equation of the line, then the first thing we're going to want to do is find the slope of a line. And the way that we find the slope of a line is the change in y over the change in x. And it doesn't matter if you write it as y2 minus y1 over x2 minus x1, or if you write it as y1 minus y2 over x1 minus x2. As long as you're consistent, and it won't matter. What I mean by consistent is, if we look at our first one up here, we have the y2 first in the numerator, and we have the x2 first in the denominator. And this one, I have y1 first, and I have my x1 first. And just as long as you're consistent, you should be fine. If you mix them up, if you write it as y1 minus y2 over x2 minus x1, then you won't get the right slope. We're going to start graphing when it's in slope-intercept form already, when the equation of the line is in slope-intercept form already. Now notice that you're looking for the form in which y is separated and on the left side or right side of the equal sign, and the coefficient on y is 1. You're looking for some value m, x, where m is your slope. That's the coefficient on x is your slope. If m is 1, so as an example, if you have y is equal to x plus 5, then your slope is 1 because there's always that 1 as a coefficient on x. And you'd have a 1, 1 slope. You'll turn it into a fraction. You'd put it over 1, just like we've talked about in our previous video. B is the y part of the y-intercept. It is not the y-intercept. Intercepts are ordered pairs. So notice that intercepts are ordered pairs, and it would be 0, comma, b. So if we take a look at our first example, they're asking for us to first determine what the slope is and the y-intercept. So my slope is that coefficient on x. So my slope, m, is equal to 2 over 5. That means my change in y is 2 and my change in x is 5. So I'm going to either, and it's a positive slope, so I'm either going to go right 5 up 2, or I'm going to go left 5 and down 2. Double negatives, or I'm going to do double positives. My intercept as an ordered pair, because these are always ordered pairs, are 0, comma, 1. And that comes from this. That is the b part, that is the y part of the y-intercept. But intercepts are ordered pairs, and you need to answer questions when they ask about intercepts. They are as ordered pairs. So we do know that our point that we're going to start is right there. It is 0, comma, 1. From there, I am going to go right 5. I'm going to go right 5, and I'm going to go up 2. So I'm going to land right there. So there's my second point. Or, like I said, I can go left 5 and down 2, and my point would be right there. This is my delta x, and this is my delta y, the change in y over change in x. On this one, this is my delta x, and this is my delta y. Now I'm going to draw a line through these points. So let me get on my line form so that you guys can see the line. Let me make it big enough for you guys to see. So here's a nice straight line using my line form, and I'm going to go through these points, and there's my line. And then don't forget, because these are lines, you do need to put arrows on your lines. Oh, let me put my arrows on my lines. So here's my line. Don't forget to put arrows on your lines because they are going on in each direction forever. All right, let's take a look at our next example here. On this one, my slope is -3. So I'm going to write my slope as -3, and because I know it's a change in y over change in x, I'm going to put it over 1 to remind myself that I do need to deal with the change in x. So delta y over delta x. My y-intercept, that is the b part, or excuse me, the y part of the y-intercept. So my y-intercept on this one will go through the point 0, comma 2. So I would go through the point 0, comma 2, which is right here. And from there, I'm going to, when I choose the negative, it doesn't matter if I put it on the change in y or the change in x. It really doesn't matter. If I decide that I'm always going to put the negative on the y, that's fine. I'm always going to put it on the x, that's fine. It doesn't matter. So I'm going to put it, for this example, I'm going to put it the negative on the y. So I'm going to go positive 1 to the right, that's my delta x, and I'm going to go down 3. So I'm going to end up right there. And then I'm going to draw my line through those 2 points. And let me choose my color so you can see a little bit better. I'll choose red this time. And make my line a little bit bigger than what I'm drawing. Okay. And so I'd go through those 2 points. And I would remember to, when I got done, to put my arrows on my endpoints to show that it's going on forever. And then I will start this one for you and I'll let you finish. Here, oh, actually, I will start this one and get it to the right form and then I'll let you finish. So this is in standard form. It's not the easiest way to graph it. So what we'll want to do is solve for y. We want to put it in y equals mx plus b. So the first thing I'm going to do is I'm going to move this 2x to the other side of the equal sign. So I'm going to add 2x to both sides. And so I have 5x is equal to, and because I have mx first, it doesn't matter, but I like to have it first, 2x and then minus 16. And then I need to divide everything by 5 because I need y as a coefficient of 1. And this is the time in which I will divide each individual term by 5 rather than each side by 5 as a whole. And what I end up with is I have y is equal to 2/5 m minus 16 over 5. So my m, actually, let me go back. Let me erase that. That should be x. Sorry about that. I was thinking m, my slope. That should be x. And so my x, I have 2/5 x minus 16 over 5. My m is the 2/5. And my y-intercept, the y part of my y-intercept is negative 16 over 5. So my y-intercept will be 0. And this is one of those times where I'm going to turn this into a mixed number because it's much easier to graph 16/5 as a mixed number than 16/5. So it will be negative, and 5 goes into 16 3 times, 1 left over. So my starting point would be negative 3 and 1/5, and my slope is 2 over 5. In these examples, they're asking us to write the equation of a line given the slope and the y-intercept, and they want us to put it in slope-intercept form. So make sure you read the directions because sometimes it'll say give the equation of a line through this point and this slope, and they want it in slope-intercept. Sometimes I want it in standard form. So make sure you pay attention to what they're asking for. In this one, they want us to use the slope-intercept form of a line, so we don't have to do as much work. My m, on this first example, m would be 2/5. This is the y part of my y-intercept, which means this is b. So my equation on this one would be y equals 2/5, that's the coefficient on x is m, and then minus 3, because that is my b part. Similarly, we have negative 1/4 is m, and it's going to go through this point. That means my b is equal to 5. My equation on this one would be y is equal to negative 1/4 x plus 5. And then on my last one, my m is negative 3 over 1 if I wish. And this gives me my b equals 0. So I'd write this as y is equal to negative 3x. I can put 0 if I want to. Typically I won't, so I'll put y equals negative 3x and leave it like that. That tells me that I'm going to go through the origin. If we take a look at what the slope is, whether it's positive, negative, 0, or not defined, We will look that if it is positive, as we read our graph from left to right, it increases. It's going up the hill. As I say, it's going up the hill. It's increasing. If your slope is negative as you read your graph from left to right, it is decreasing, and it's a negative slope. Let's say it's going down the hill. If you have a horizontal line, then your slope is 0, and that's because your y1 is equal to the same thing as y2. Your y's are not changing at all, and you'd have an equation of a graph that looks like something is equal to, and I'll call it b, because it's going to go through the y-intercept. The y-intercept will be where it is, so y is equal to b. My last example is a vertical line, and it's undefined, and that's because your delta x is 0. You're not going left, you're not going right, there's no change in x. So delta x is 0. And we know that when we have delta y over delta x, where x happens to be 0, I'm trying to divide by 0, and we know that when 0 is in the denominator, it's always undefined. And in this case, you would have a line where x is equal to some number. Some number. All right. Now, let's take a look at the point-slope form of a line, equation of a line. When you have the point-slope form, that means you have a point and you have the slope. This is one equation of a line. Again, it's not the best equation of a line to graph. You could, but you're just not going to start. Your starting point wouldn't be b, and you could graph it from here. When you're looking at this equation, you've got this x1, this y1, and this x1. What those are is a point, because you're going to be given either a point and a slope. So you'd be given, say, x1 comma y1 and some slope m, or you may be given a second point, so x2 comma y2, and you'd first need to find the slope. Now these y1s and x1s, if you prefer to use the other point, you can. You don't have to use the first point, you can use the second point. There's going to be times where you want to use the second point, but you still need to find the slope first if that's the case. And so the first thing you would do is find the slope, and you'd have m is equal to y2 minus y1 over x2 minus x1. On the next page, we're going to look at some examples where we're going to go through it completely, where we first have to find the slope and then use the point-slope form, and then we may be asked to put it in slope-intercept, we may be asked to put it in the general form. We'll see what happens on the next page. Here is a summary of all the forms of a linear equation. Our first one is the standard form. We've talked about that. Second one is the slope-intercept form. We've talked about that one. Next one is our point-slope form. You know a point and you know the slope. You would use that one. Horizontal line, we have y is equal to c, where actually we want to say b because it's where it's going to cross the y-axis. And then x is equal to c is our vertical line. Parallel and perpendicular lines. Let's just talk about that for a minute. If my two lines are parallel, they have the same slope. When they are parallel. If the slopes are perpendicular, so if they're perpendicular, and I multiply those two slopes, then the result will be -1. In other words, my perpendicular slopes will be negative reciprocals of each other. So as an example, let me move this over a little bit. As an example, say the slope of one equation is -2, then the slope of the second for perpendicular, and I'll write that straight line with a straight vertical line and a straight horizontal line means perpendicular. So the perpendicular line M2 would be a negative reciprocal. So if this is negative, my slope on my other line that's perpendicular would be positive. And since this is, even though it's not there, I can write it as 1. And so it would be 1/2. So if I were to actually multiply these two slopes, if I take M1 and multiply it by M2, then I would do -2 over 1 multiplied by 1 over 2, and we can see that this does equal -1. But the gist of it is, if they are parallel, they have the same slope. If they are perpendicular, then they are negative reciprocals of each other. In other words, one will always be positive, one will always be negative, and when I multiply the two, it will give me an answer of -1. So let's go back over here. There are two things that you need to have to be able to write a linear equation. You need to have a slope, and you need to have at least a ordered pair. If you're given two ordered pairs, then the first thing you have to do is find the slope, and you're going to pick one of those 2 points, and you're going to use a slope-intercept form. So let's take a look at our first example and see what it is that we have and what it is that we need to do. So our first example is they're asking us to find an equation of a line. They want it in slope-intercept. They give us our slope, and they give us a point. This is not the Y-intercept. That's not the point. So I don't get to go quickly to the slope-intercept form. Well, we'll do it 2 ways. So the first thing I'm going to do is I'm going to use a point slope form. So I have y minus, I come over here, this is my x1, this is my y1. So I have y minus 7 is equal to, my slope is -2, and then I have x minus my x1 is 1. There's an equation of a line, it's not a slope-intercept form. So what I would do is I would distribute the -2 onto those 2 terms. So I have y minus 7 is equal to -2x plus 2. I need y by itself, so I will go ahead and add 7 to both sides, stack it under like terms. And I end up with y is equal to -2x plus 9. Now, that's using this equation. So I used this equation right here to find my equation of a line in slope-intercept form. Now, you may have, I'm totally fine if you do it this way, you may have learned it this way. You may have used the y, let me put that in black, you may have used this, y is equal to mx plus b, and if you used this, and I want to talk about this as a separate way of doing this, so let me show you that this is a separate way of doing this, that you would have done it as this way. You would have used the y, you would have put in right here, you would have used this point. So you would have had 7 is equal to, you would have used this m, still the same, right there. So you would have put in -2. You would have used, for your x, you would have used this point, so that's 1. Let me put that in black. So 1. And then plus, and in this case you would have solved for b. This is totally fine. If you do it this way, that's fine too. Slope-intercept form will work as well as point slope if you already have the slope and you're just looking for the intercept. In this case, though, there's more steps than just being done and solving for b. You have to go back and rewrite it in the right form. If you use point slope, you just do the algebra, walk your way through, and you're done. So this, if you learned it this way, I'm fine with it. If you haven't, you don't have to do it this way. Either way, it doesn't matter. Let's finish this. So we have 7 is equal to -2 plus b. We are going to add 2 to both sides. And so we have 9 is equal to b, but all you've done is solve for b. You then still have to go back and put it into this equation with the correct m value. So you would go back and say y is equal to, we have the -2x plus 9. It's the same thing. I got the same place. It's just, if you learned it this way, like I just showed you, that's fine. If you learned it this way, that's fine too. My preference, until you get really comfortable with lines, is you use it this way because it is just a matter of solving for y. You don't have to go back and say, oh, all I've done is found b, and then put it back in the equation. This is already there. Again, though, it doesn't matter. It doesn't matter which one you use. As long as you're consistent, you should be fine. These next 2 examples are similar to the one I just did. So pause your video here, see if you can do B and C, and then restart it and see if you get the same answers that I have. So the answer for B, when you write it in slope-intercept form, is y is equal to 2/3 x. And I'm going to, since I have these are my y part of the y-intercept, I'm going to write these as mixed numbers, and so I'm going to write this as -1 and 2/3. For C, I got y is equal to -1/2 x, and again, I'm going to write this as a mixed number, so I'm going to write plus 6 and 1/2. That allows me to quickly graph the line. This one is different. This one I have to find an equation of a line through the points 4, 0 and -4, 5. So the first thing I have to do is find a slope. I don't have the y-intercept, I have an x-intercept, and I still need to find the slope. So the first thing I'm going to do is find slope, ym. I'm going to go ahead and label these for my own knowledge. It makes it easier for me to do this. x1, y1, x2, y2. And so I know this is going to be a y1 minus y2 over x1 minus x2. And so my slope is going to be 0 minus a negative 5 over 4 minus a negative 4. So my slope is going to be a positive 5 in the numerator. And I have 4 minus a negative 4, so it's positive, so it ends up becoming 8. So there's my slope. It doesn't matter which point I use. I'm going to actually use this point right here because one of my values is 0. So I'm going to use that one. So using the point slope form, I have y. Let me write this in red. So I have y minus y1 is equal to m x minus, that's not x1, x minus x1. So I'm going to use that point, and so I have y minus 0 is equal to 5/8, and then x minus 4. That's an equation of a line. I could stop right there, but I'm going to put it in slope-intercept. It doesn't say, it just says an equation of a line. That is an equation of a line. I could, if it doesn't say anything else, stop there would be a correct answer. But I'm going to go ahead and write it in slope-intercept form. So y is equal to, because that 0 is not important in writing it the second time, y is equal to 5/8, and I'm going to distribute the 5 here and the 5 there, or 5/8, excuse me, distribute the 5/8 onto both of those. So I have 5/8x minus, and I have 5/8 multiplied by 4. I'm going to write this over 1, so I can do some cancellations here. 4 will go into 8 2 times, 4 will go into 4 1 time, and so the equation, if I wanted to write it in slope-intercept form, is 5/8x minus 5 over 2. Actually, I'd probably write that as a mixed number. All right. Find the equation of a horizontal line containing the point 1, negative 3. Now remember, a horizontal line is of the form y is equal to b. That's the y-intercept. But we don't seem to have the y-intercept here. We have an ordered pair and it's not on the y-intercept. Well, because it's a horizontal line, we're going to do a quick little sketch of a graph. Horizontal line is going to go through this point, 1, negative 3. So let me actually put the line where it belongs. It goes through this point right here, 1, negative 3. Here's 1, negative 3. That my b value happens to be negative 3. So this is going to be my b value because it's a horizontal line, so I can write this as y equals negative 3. Equation of a vertical line, do a quick sketch, y and x, needs to go through the point 2, 7. So right 2 up 7, so it's going to need to go through this point approximately right there, so it's going to have to look like this. So I know it's crossing the the x-axis at 2, and so my x is equal to 2, because it's going to be right here. This next example is similar to the 2 I just did, so what I want you to do is go ahead and pause your video, and then try this one on your own, and then restart it, and let me know if you got the same answer as I do. So hopefully you've got the equation of x is equal to 6, because the undefined slope tells me it is a vertical line, which means I just use that part of the ordered pair to find the equation of a vertical line. On these examples on this page, we're going to talk about parallel and perpendicular lines. So just as a reminder, move this up a little bit, parallel lines, if two lines are parallel, if we have m1 is the slope of one line, and m2 is a slope of the other line, they have to be the same for parallel lines. For perpendicular lines, they have to be negative reciprocals. So in other words, when I multiply m1, m2, I should get a product that gives me of -1, and that's for perpendicular. So our first one, they're asking for a line, equation of a line, that contains this point, and it's parallel to this given line. So what I need to know what the slope of the given line is. And I can write this as y equals, I can put it in slope-intercept form, that's totally fine. And if I do that, I end up with, I'm going to subtract off 2x, put it right here. not there. And so I've got 3y is equal to negative 2x minus 6. I'm going to go ahead and divide everything by 3 individually, each term individually by 3. And so I've got y is equal to negative 2/3 x minus 2. That's the equation of the given line. So I know the slope of my parallel line has to be the same, so it has to be this. So, and I have a point, so I'm going to use the point slope form. I have y minus 4 is equal to negative 2/3, and then I have x minus 4. It does not say I have to write it in any particular form. There's an equation of a line, I'm done. But if I want to write it in slope-intercept form, I would go ahead and continue a little bit further, and so I'd write y minus 4 is equal to, I'm going to distribute through, and so I have negative 2/3. Let me put that in black. I have negative 2/3 x minus minus minus, so a negative 2/3 and a negative 4 becomes positive, and I end up with 8/3. And then I still need to move my 4 on the left side to the right side, so I'm going to add 4 plus 4, and so I have y is equal to negative 2/3 x plus, and I'm just going to, right here, I'm going to do some adding of fractions. I have 8/3 plus 4, which is the same thing as 8/3 plus 4/1. Same common denominator, so I need to multiply this by 3 and the numerator and denominator both by 3. And so my fraction ends up being 8/3 plus 12/3, which gives me 20/3. So back to my equation of my line, I have plus 20/3, and I could write that as a mixed number. All right. On the next one, I want to find an equation of a line that is perpendicular to that equation, and that is through that point. So here's my given line, which is fortuitous for us. If we take a look, it's actually the same equation as above. So we already know what the slope is. And we need to go through this point. Now, this slope right here for M1, we'll call this line 1, so M1, is a negative 2/3. That means my other slope have to be the negative reciprocal. Because my first slope is negative, my second slope, or the perpendicular slope, will be positive. And reciprocal just means that instead of having 2/3, it's going to be 3/2. So again, I have y minus, using the same point, y minus 4, is equal to positive 3/2 x minus 4. Y minus 4 is equal to, I distribute, and I have oh man, sketchy. I have 3/2 x minus 3/2 times 4, and I'm going to write this over 1 to make my life a little bit easier. So 3/2 times 4/1, I have some cancellations, and so I end up with minus 6. Let me show you really quick what I'm doing with the fractions there. There's my fractions. So I was doing 2/3, man, not 2/3. I was doing 3/2 times 4/1, and so I have 2 goes into 2 once, 2 goes into 4 2 times, and I end up with 6, and that's where that 6 comes from. So now I need to still solve for y, and I'm going to go ahead and add 4 to both sides, so plus 4 and plus 4. And so my final equation, if I needed to write it in slope-intercept form, would be y is equal to 3/2 x, and then minus 2. All right. What I want you to do now is I want you to pause the video and try this one on your own. It's giving you a line, it's giving you 2 points, and it's asking you to find the equation of the line in standard form, and then find an equation of the line perpendicular to that through that given point 0, 4, and then graph the line. So go ahead and pause it, try it on your own, and then start it, and let me see if we have the. All right, now because it's asking for it in standard form, when you get done, it has to have a form that looks like this: ax plus by is equal to c. And that isn't going to fall out. So the first thing we're going to have to do, hopefully is what you did, is determine what your delta x was and what your delta y was from point to point. And you could do it as ordered pairs, and you can use the slope, or you can just count. Now be aware that each grid mark is not 1, each grid mark is a half. And so what I got my slope to be on this line that's given, m, is I went up 3, so that was my delta y, and I went right 4 from point to point, so I ended up with the slope of 3 over 4. I'm going to use this point. This is the point -1, 2. So I use that point, I'm going to use the point slope form, which is y minus 2 is equal to 3/4 x minus a -1. So I have y minus 2 is equal to 3/4 x plus 1. Now, what I need to do is I need to put it in ax plus by is equal to c. So I'm going to go ahead and clear my fraction. What I mean by clearing my fraction is I have a fraction right here, and I want to clear that. I don't, if I can avoid fractions, I'm going to. It's not that I don't like them, I'm just going to. So that means to me that I'm going to multiply both sides by 4, because that will clear my fraction. So in other words, I'm going to multiply this by 4 over 1, and I'm going to multiply each one of these by 4 over 1, or just 4 if you like. And so my equation is 4y minus 8 is equal to 3, because this 4 right here canceled with that 4 right there, x plus 1. I'm going to distribute the 3 through, so I have 4y minus 8 is equal to, and I distribute the 3 here and here, and so I have 3x plus 3. I can go left, I can go right, because standard form, I can write it up here as ax plus by equals c, or I can write it as c is equal to ax plus by, and I like to have x positive. Doesn't matter, it's just me. So I'm going to move the 4y to the right, and I'm going to move the 3 to the left, and I end up with -11 is equal to 3x minus 4y, and I can leave it like that, or I can just rewrite it as 3x minus 4y is equal to -11. Now that is the first part of it. All that is doing is saying I have wrote the equation in standard form of the line. Now it's asking me to find the line that is perpendicular to that line and goes through the point 0, 4, and I need to graph the line. Now it's fortuitous that this happens to be the y-intercept, so it makes my life a little bit easier. So if I had to graph this, or excuse me, I will graph it. If I had to find the equation of the line, I know what my slope is. So this is the slope of the first line. That means the slope of my perpendicular line must be negative reciprocal, which means if that's positive, if the first slope is positive, my second slope must be negative. And since the first slope is 3 over 4, my perpendicular slope must be 4 over 3. So I have y is equal to -4/3 x. Remember my b is 4, so plus 4. And I'm done. That's the equation. If I needed to write this in standard form, then I would do like I did before, is I need to clear this 3, and so I'm going to go ahead and multiply each of my terms by 3 over 1, or just 3, and both sides of the equal sign. So I would end up with 3y is equal to -4x plus 12, and I would add 4x to both sides, and so my equation would be 4x plus 3y is equal to 12. And notice if I do a comparison of these two, let me zoom out. Notice if I do a comparison of these two, what happens? What happens to the coefficient on x? What happens to the coefficient on y? And then lastly, what happens to the sign between these two when they're perpendicular? Something to contemplate. Okay, now we're going to graph this. So I need to go through the point. They tell me I had to go through the point, and I'm going to do this in red. I need to go through the point 0, 4, so I need to go there. And my slope is -4/3, so I'm going to drop 4. Here's my delta y, and I'm going to go right 3. There's my delta x. And so the equation of my line is, let me choose a bigger, there we go. Equation of my line, we'll go through this point and that point, and then don't forget to draw the ends of your line with arrows. So there's my arrow, and there's my arrow. Okay, there you have it. This example is similar to the last example that I did, with the exception of what we're looking for parallel lines. So go ahead and pause your video right here and try it on your own, and then come back and check your answers with mine. The answers that I have for the original equation, for at least the equation that's graphed, is I got, and I'll do it in black, as I got the equation of the line that is graphed to be in standard form, to be x, oh, I want to do this in black, sorry about that, let's do this in black, to be x plus, and I have 7y is equal to, and -4. The equation of the line that's parallel, that goes through the point 0, 1, in standard form, I have this, and I'll do it in blue, is x plus 7y is equal to 7. Now notice these are parallel lines. Notice the coefficients on the x, the coefficients on the y, and the sign between the two on each equation. Let's take a look at that. All right, we also had to graph this. It had to go through this point right here, and I'll do this in blue, so it has to go through this point right here. It has the same slope, which should be a -1/7. So from here, I would have gone over 7 and down 1. So here's my line. Let me do my line as a straight line. Over 7, down 1, and it should look something like that. And don't forget to put your arrows on these, and there's your parallel line. Now, let's do some applications. Looking at our first application problem, we have some office equipment that was purchased, and we want to find the linear equation that relates V in dollars to T time in years. Typically, for these type of applications, we want to think about as the time being the x, or independent, and the value after a certain amount of time being the y. If we were to graph this on the xy plane, we would actually use not x and y, we'd actually use t in time, and y would be money. So we have a couple ordered pairs here. We have this one here. This is how much it was when we purchased it initially. So our ordered pair actually is at, when our initial purchase, or at time 0, we have $20,000 is the cost. And then our second ordered pair is after 10 years, we have $2,000. So our second ordered pair is 10 years and $2,000. All right, so that means we need to find the slope. So let's find the slope, m. M is going to be equal to, and I'm going to call this x1, y1, x2, y2. And so I have 20,000 minus 2,000 over 0 minus 10. And so the slope is going to end up being a -1,800. So now I have the slope, and I need to find the equation of the line. So I'm going to use the point slope because I have a point and a slope. So I'm going to use this equation. Let me write it. Y minus y1 is equal to mx minus x1. And I can use either point, but I'm going to use the first point because I have 0. So for x, which means I actually could have just put it right into the slope-intercept form because I have b. And so that's what I'll do instead. Again, the slope-intercept form is y is equal to mx plus b. And so I would put it in that form, but remember, I have these variables. My time right here would be what my x is, and my value, or my dollar, is what my y is. And so my equation is going to be b, that's my value in dollars. My slope was a -1,800 times t, and then I know this right here is my b value, so plus $20,000. Or you might see it this way: V is equal to the initial amount, $20,000, minus the depreciation with respect to time. All right. In our next example, let me take that off there. Let's take a look at our next example. We're going to be looking at supply and demand. So we're talking about a free market, supply and demand, and we're looking at the relationship between supply and demand. If we look at the relationship between supply and demand, the price will stabilize at the point where the supply equation equals the supply or the demand equation. So that point of intersection is called the equilibrium point. The price that is, which would be our x part of it, would be the equilibrium price, and the supply and demand would be equal, and it would be the equilibrium quantities. For example, we're going to be looking at bushels of barley at years 2002 and 2003. Here's our supply in millions of bushels. That's MIL is for millions, BU is for bushels, and then that's the price per bushel. Don't ask me what a bushel is. As far as we care, it's just some sort of unit of measure, and if you want, you can email me and let me know what a bushel is in terms of the unit. Anyways, let's go ahead and start this equation, or let's go ahead and start this application. The first part of our application is asking us to find the supply equation in the form P is equal to MX plus B, where P is the price in dollars and X is the corresponding supply in millions of units. So if we look on our previous example, or chart, I'm sorry, not example, our previous chart on the previous slide, we're going to use the price is going to be our Y value, and our supply is going to be our X value. So our first set of points, if you go look in the previous slide, is we're going to use the 2002, and so we have our supply is 340, and this is in millions, but I'm not going to put millions, I'm just going to use 340, and the price at that point was $2.2 per bushel, and our other point that we're going to use is the 2003, which was 370 millions of bushels, and our price was $2.72. So we have our Y1 and our Y2 and our X1 and our X2, and we're going to find our slope. And I found the slope to be, I ended up with a negative 0.5 over 30. So I wrote this as a negative, I'm sorry, it's a negative 0.5 over negative 30, double negatives, and I wrote this as an equivalent fraction, and I got 1 over 60. Now, that's the exact slope. If you want to give an approximation, then this is approximately equal to 0.016 repeating. So that was my M, and then I used the point slope form of an equation of a line and cleared it to make it to be P is equal to, and so my equation that I have is P is equal to, and I'm going to use the 0.016 repeating, and then I have X, and my B value I found to be negative 3.45. So go ahead and work that one out and make sure that you got the same answer I have. I'm going to do the same thing for the equation of the line for the demand, and so I'm going to be using the demand and the prices. My demand is going to be my X, so I use the point 270 in 2002 with a price of 2.2, and in 2003 I had a price of 250, and I have a price of $2.72. When I did this one, my slope ended up being a negative, and I got negative 0.1 over 4. In other words, this is a negative 1 over 40, and if you want to write it in a decimal form, this is equal to negative 0.025. Again, I would use a point slope form of the equation and then write it in slope-intercept, and so for this one I have P is equal to negative 0.025 X, and my intercept on this one was a positive 8.97. Okay. Now it's asking me to find the equilibrium point. So in other words, I'm going to put the two equations I found, the equation in A and the equation in B, and I'm going to set them equal to each other. So let's do that. My first equation that I found was the 0.016 repeating x, and my b value on that one was minus 3.45. And it's going to equal my second equation, which is negative 0.025x plus 8.97. Let's go ahead and bring our x's to the left. So I'm going to add the 0.025x to both sides. And I'm also going to add the 3.45 to both sides. So on my x's, I add these together. Now, when I added these, because one is a repeating, I went back to the fractional form. I added 1/60th plus 1/40th, and so I ended up with 0.0416 repeating x. And then on the other side, I ended up getting 12.42. I need to solve for x, so I'm going to go ahead and divide 0.0416 repeating and 0.0416 repeating. And again, I actually used my decimal. I did my fractions on these so I can get the exact. And I've got x is equal to, and I ended up with 298.08. And so that gives me my x value. So I know what my equilibrium amount is. That's x. But I still need to find my y value. And so I need to know what the price is. And so I'm going to take this x value, I'm going to put it into one of the two equations. It doesn't matter which. I'm going to go ahead and put it into the first equation. So I'm going to put that into the 0.016 repeating. X was 298.08. And minus the 3.45, and I'm trying to figure out what my equilibrium y is. And so when I do that, I've got the equilibrium price. I ended up with $1.52, because I'm going to round 52 cents. And so my equilibrium price is $1.52. So I'd write that as a full sentence. Equilibrium price is $1.52 per bushel. I'll just put BU for bushel. The equilibrium supply, or amount, is 298.08, and this is millions of bushels. So it's not 298 bushels, it's millions of bushels. And then I would graph these two lines to confirm that they actually cross at that point. And thank you for watching.